In this session we are going to discuss about the process concepts and process scheduling. The main objective of this session is to introduce the notion of a process and to describe the various features of the process, which include scheduling, creation and termination of the process. In general, an operating system executes a variety of programs such as batch system and in the time shared system. So we can generally define the process, which is said to be a program in execution state, and this process execution must progress in a sequential fashion. A process which includes the major parts of program counter, stack and then data section. Apart from this, the text sections are there, so which contains the program code. Program counter is a processor register which will include the next instruction to be executed by the CPU, and the stack contains the temporary data such as function parameters, return address and local variables. We can able to differentiate the program with the process. Program is a passive entity, whereas the process is an active entity, because the program counter will be including the which instruction to be executed by the CPU next. So the process is said to be an active entity, but the program is a passive entity where the program code is a dump in the secondary storage. And at any point of time, the process will be in any one of these 5 states: new, ready, running, waiting and terminated state. If a new process is arriving into the system, and that will be put into the ready state, so where the process will be waiting to acquire the control of the CPU for execution. So after it is in a running state, the task is completed, then the process will be put into the terminated state. In the middle of the execution, if any IO or event wait to be happen, then the corresponding process will be in a waiting state. After the completion of IO or event, once again that process will be put into the ready state. With the help of the scheduler and dispatcher module, the process will be picked from the ready state and that will be executed by the CPU. In between, if any of this hardware or software interrupt occurs, the process will be again put it into the ready state. Once the turn is given, again the process will continue its execution and finally it will get terminated. N number of processes will be there in any point of time in the system. So how we can able to uniquely identify a process in the system? With the help of the process control block, otherwise it is called as PCB. Under this PCB, so the relevant information about the process will be residing, such as process state, program counter, CPU register, etc. So this is pictorially representing the process control block. We can able to define how the CPU will be switching from process to process. So consider two processes are there, process P0 and process P1. Initially the process P0 is in executing state. If any interrupt or system call occurs, then we are going to save the state into PCB0 and reloading the state from PCB1. So now we are going to give the control to the process P1 or the CPU. After that it will be starting its execution, and in the middle of the execution the interrupt or system call occurs. So once again we will be saving the state into PCB1 and reloading the state from PCB0. Then from that particular point of time the process P0 will get continued. So this we have pictorially represented as a diagram, which means that it is said to be the context switch. So this is a reference we have taken from the Operating System Concepts by Silverskach Galvin. Thank you.